Okay, this is F.IF.7.a, Functions, Interpreting Functions, Standard 7, Subpart A, Video 1. We are graphing quadratic functions in the form of y equals ax squared plus bx plus c. And the difference in this lesson is we have added on this middle term of the trinomial called bx. So we're going to look and see how that is going to be shown today. A few terms to know. I'd like you to jot these down in your journals and define them. This is a very scary looking page. I wouldn't worry too much about it. We're going to go through each one of these steps in order to graph this trinomial. The first thing we're going to do is locate the axis of symmetry. That's kind of our mirror points. We've been used to using the y-axis. Let's write that out. We've been used to using the y-axis as our axis of symmetry, and the equation for the y-axis is x equaling 0, because if you were to plot all of the points on the y-axis, 0 is always going to be your x-coordinate, which is why we call it x equals 0. Now when we graph this trinomial up here, with this additional term here in the middle, there's going to be a relocation of the axis of symmetry that we're used to using. All right, the first step, let's find what that x is equal to. Let's find out what that axis of symmetry is. And in order to do that, we're going to use an equation or a formula that is given. And I'm going to need you to memorize this. X is going to be equal to negative the fraction of the b term over 2 times your a term. And let's put that to use right away. We have a being the coefficient of your x squared. B is the coefficient of your x to the first power. And then your c term is your constant value, your integer there at the end that is not attached to an x. All right, so it's simple substitution and mathematics computation. So let's substitute x is equal to negative. That's going to be important later on. The fraction of b, well, b in this particular case is a positive 6. Make sure that we notice here the sign in front of that number. I'm even going to write it in as a positive 6. All over 2 times your a term. Well, the a term is invisible, but we know that there's a positive 1 there. So let's put in our positive 1 and continue to simplify. We have negative the fraction of 6 all over positive 2. Let's continue. Positive 6 divided by positive 2 is positive 3, and attached to that positive 3 is that negative that we started with in our formula. So we have a negative 3 for the x term. X is equal to negative 3. All right, so when we graph that, we're going to be relocating that mirror or axis of symmetry. Let's just go do that right now. We said that it's going to be located at, let's scoot this over a little, at negative 3. So let's draw in a point there. It's actually going to be a line. So let's draw in our line there. If this was x equaling 0, we're going to go x equaling negative 1, negative 2, negative 3. And there is the axis of symmetry. Let's make that bigger. How about that? Okay, that's the first step in the process of graphing this quadratic function. Now the next part is finding the vertex of the graph. That is going to be either the highest point or the lowest point of the parabola, and we would call that either the maximum or the minimum All right, so in the maximum, your parabola is going to be going downward, and your vertex is going to be at the tallest point of the parabola, or the highest point. That's why it's the maximum. And if we have a minimum value of the parabola, it's going to open upwards, and that would be the minimum point of the parabola. So here's your maximum, and there's your minimum. Why don't you pause the video and copy that down, because I'm going to erase it here in a second. Okay, now finding the vertex, we are going to use that x value kind of like a function table. We have an input and an output. We now know that our x is -3, and if I need the output, I'm going to have to take that -3 and substitute it in wherever I see an x in my original equation, and that input will then compute to give us our output. So let's do that right now. I'll just recopy this. Oh, you know what? Yeah, let's recopy that. And now we do our substitution. So y is equal to whatever the x is. We'll put it in parentheses because of that. These negative signs are tricky. So -3, that value inside is going to be squared, x squared, plus 6 times that x. Well, that x was -3, we stated. And then we bring down our +2. All right, let's do order of operations. -3 squared is 9. 6 times -3 is -18 plus 2. Continue with the order of operations. 9 minus 18 is -9. Oh, let's write it out. So we have -9 plus 2. So the y value is going to be equal to -7. All right, let's go to our graph and plot that -3, -7. So we go 1, 2, 3, 1, 2, 3, 4, 5, 6. Looks like I need to go up one more here. Let's go up a couple. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and there is the vertex. Now we have to decide whether or not this parabola is going to have a minimum or a maximum. And since our a value is greater than 1, so if a is actually greater than 0, if it's greater than 0, we know that it is a positive a and it's going to open upward. And if that a was a negative, we have learned that that is going to be opening downward. It's that reflection we spoke of. So then this one is going to have a minimum. So it's going to be at the bottom of our parabola. Okay, so let's look at our graph, make sure we have enough room to open upward, and it looks like we do. So how do we get the rest of this parabola? Well, in order to do that, we have to make up 2 more inputs. So if we have our table of values, our function table, input and output, my first vertex, where we begin the parabola, we said was -3, -7. And now, according to rule, we have to choose 2 x values that are less than the original x coordinate of the vertex. So if I have x being -3 and I need 2 points that are less than that, I can choose -4 and -5. You can actually choose as many as you want. I have found that the third value is really going to help you see the parabola grow. You know, if you don't have enough points, you're not really going to have an idea of how this parabolic function looks. All right, now that's a great table. How do I get the rest of my ordered pairs? Well, it's exactly what we did when we found the y value for the vertex. We're going to take our inputs and substitute them into the original equation and solve for the outputs. So I'll do the first one, and then I'll pause the video, and you can finish off the rest of the table. All right, so when the input is -4, the output will be -6. Please pause the video and finish off these last two values in the function table, and then we're going to go ahead and graph all these ordered pairs. Okay, we are back, and if I've done my calculations correctly here, I did that kind of quick. I hope we came up with the following table. We're going to take these ordered pairs and we're going to go graph them. So we have the original vertex. We now have a point called -4, -6, -5, -3. -4, -6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. We have the axis of symmetry to get the other side. We go 1 from the axis and 1 to the other side. Let's go find that other point. We had -5, -3. So we go 1, 2, 3, 4, 5, -1, 2, 3. Let's count it over from our mirror. Axis of symmetry, 1, 2 over, 1, 2, plot the point. And now for a little bit more accuracy, let's go ahead and plot the point -6, 2. So we go 1, 2, 3, 4, 5, 6, 1, 2. And then from this axis of symmetry, we go 1, 2, 3, 1, 2, 3. And now you get to do a little freehanding with the parabola. Let's see how we do here on this board. Connecting the points. Little rounded edge here on the bottom, little rounded parabola. Put some arrows on the top of it. And you have just graphed the given equation of y is equal to x squared plus 6x plus 2. Okay, in your journals, I'd like you to define the given terms on page 2 of the flip chart. Write a few sentences on what you've learned from this video. If you have any questions, make sure you write them down and bring those questions to class so we can all answer them together.